Example 8. Find the probability of being dealt the given hand from a standard 52 card deck. In part A, we're going to look at a 5-card hand that consists entirely of face cards. All right, so we're back to counting hands of cards that meet certain criteria. Okay, we did a lot of this in section 7.4. Okay, so it's back, so you'll get more practice with it. But now your answer has to be a probability, which means your answer has to be a number between 0 and 1. Okay, how likely is it that you will be dealt a hand that fits this criteria? Okay, so keep that in mind. You're going to be counting, but your final answer will be a probability. Okay, all right, so we are still dealing with our hands being dealt out of a standard 52 card deck. For part A, we're going to look at a 5-card hand, and that 5-card hand has to consist entirely of face cards. Okay, so to come up with the probability, okay, the probability, I'll put H, the probability of this hand, H is for hand, the probability of this hand occurring, okay, how do we compute it? Well, remember, you're going to have a fraction. What goes in the top? What goes in the bottom? The bottom is going to be the total number of all possible 5-card hands. Okay, because we're trying to compute the probability of being dealt a specific 5-card hand. Okay, so we've got to take a look at all the different possible outcomes, and all the possible outcomes, what those are all the possible different 5-card hands that are possible. Okay, all right, so the numerator is going to be all the outcomes that fit this bill. Okay, so it's going to be all the 5-card hands that consist entirely of face cards. Okay, so we need the total number of all 5-card hands consisting entirely of face cards. I'll put FC for face cards. Okay, so that's how we're going to do this. Okay, we're going to have to count up 2 different things. Okay, we'll start with the denominator. We're going to first count the total number of all possible 5-card hands with no restrictions. Okay, so I will put that in, I guess I should have color coded this, I know for next time. Let's put this denominator in red. Okay, so remember when we talked about this in section 7.4, if you are dealing with a hand of cards, that is a combination. Okay, so we're going to have a combination to figure this out. Okay, you're going to be choosing from the entire deck, so all 52 cards are game. Okay, and you're going to be selecting them, or you're going to be putting them in groups of 5 because your hand consists of 5 cards. Okay, so this is how you're going to get the denominator. Okay, you do this combination, it's going to give you the total number of all the possible 5-card hands that there are. Okay, so let's go to the calculator and figure this out. All right, so we're going to go and put in 52 math, go over to probability. We're going to choose option 3 for combination. So 52, choose 5. Okay, so there is going to be our total number of 5-card hands. Okay, so let me write this down. I think that's right. Let me double check it. Okay, there we go. All right, so remember, this is going to be our denominator. Okay. All right, so now we've got to go back and deal with the numerator. Okay, how many 5-card hands adhere to this condition? How many are made up of entirely face cards? Okay, so we expect a number much smaller than this. Okay, because we're looking for a subset of all 5-card hands. Okay, all right, so I'll put this in a different color. I'll use green here. Okay, so to get the numerator, okay, you're still dealing with a hand of cards. Okay, you just want all 5 cards to be face cards. Okay, so it's going to be a combination. Okay, you're still going to be choosing 5 cards because there's going to be 5 cards in your hand. But you're not pulling from the entire deck now, okay? You want to ensure that you have all face cards, okay? So you're only going to be pulling from the set of face cards, okay? So if you go back to your deck, and let me erase what we've done from some previous videos, okay? If you look at your deck, okay, we're interested in only the face cards, okay? Remember, face cards are jacks, queens, and kings, okay? So there are 3 face cards per suit, okay? There's 4 suits, so there's a total of 12 face cards, okay? So that means we're going to be pulling from those 12 face cards, okay? So from the 12 face cards, we are selecting 5 of them, okay? So that's how we're going to get the numerator, okay? So let's go put this in. Okay, so we're going to do 12, choose 5, and there's our numerator, okay? As expected, a lot less than the denominator, okay? This is the probability, okay? Very strange fraction, okay? But that's it, okay? I will go ahead and write down the decimal just so you can get a gauge of how likely this is. Usually when you look at the fraction, you may not have such a good feel for how probable this is, okay? So you take the numerator and divide by the denominator, okay? You can see when you look at this, you might say, oh my goodness, I got a number bigger than 1, but you actually didn't, because look at this, you've got this e to the -4 power, okay? So that means you've got a really, really tiny decimal, okay? So if I had to translate this, let's see, it's going to be 0.0001234, okay? So it looks like this. Okay, and it kept going. Okay, so if you move the decimal point 1, 2, 3, 4, actually, I think I have one too many zeros. Okay, but you get the idea here. This is going to be a teeny, teeny decimal, which means that being dealt a hand like this is not very probable. Okay, so 1, 2, 3, 4. Okay, there it goes. Okay, so it's got 3 zeros in front. Okay, or sorry, three zeros behind the decimal point, and then your 3. Okay, so this is 0.0003, and then it keeps going. Okay, so this is not very likely to be dealt a hand like this. Okay, all right, let's take a look at the next one. Okay, you're still going to do the same thing. Okay, to figure out the probability of being dealt such a hand, your denominator is going to be the total number of all possible hands of that size, and then the numerator is going to be the total number of all hands of that size that meet the criteria you're looking at. All right, so let's take a look at part B. Okay, so now we're looking at 6 card hands. Okay, and we want to be dealt a 6 card hand that contains exactly 2 clubs. Okay, all right, so let's start with the denominator, or let's actually write down how we're going to compute this. Okay, so for the probability of this particular hand, okay, the denominator is going to be the total number of all possible 6 card hands. And then the numerator is going to be the total number of all 6 card hands that contain exactly 2 clubs. All right. So first things first, let's deal with the the denominator, because that's usually easier to deal with. Okay. So again, I'll put that in red. Okay. So the bottom, and I'm actually going to move this down because I think the numerator is going to take a little bit of work. All right. So let's go down here and talk about the denominator. Okay. You're being dealt a hand, so it's a combination. Okay. If you're trying to figure out the total possible number of all 6 card hands, okay, with no restrictions, remember you're going to be you're being dealt that 6 card hand from the entire 52 card deck. So you would be pulling from the entire deck, and you're going to be choosing 6 cards. Okay, so the total number of all possible 6 card hands is going to be 52, choose 6. Okay, so since we're here, let's go ahead and compute that on the calculator. Okay, so I'm going to clear out my previous work. So we're going to do 52, choose 6. Okay, there's the number of possible 6 card hands. Okay. All right, so there we go. And let me put some commas on here so it's readable. All right, so there we go. Okay, now we've got to work in the numerator. Okay, the numerator is going to be a subset of this number. Okay, we're looking for very specific 6 card hands. Okay, we want the 6 card hands that contain exactly 2 clubs. Okay, all right, so we expect this to be a lower number than this. Okay, all right, so let's talk numerator. Okay, you're still going to have 6 cards in your hand, but you want 2 of those cards, exactly 2 of those cards to be clubs. Okay, you can't have 3 clubs. You can't have just 1 club. You have to have exactly 2 clubs. Okay, so we did do something like this in section 7.4. Okay, remember, you want 2 of them to be clubs, but when you're setting up the combination, you have to account for all the cards in your hand, okay? So let's start with the condition on the clubs, okay? So we're going to have a combination, okay? We need exactly 2 clubs in our hand, okay? So to ensure that we're getting clubs, we're going to have to pull from the clubs, okay? So we know that the clubs are an entire suit. So that means there are 13 clubs in the deck. So we're going to be pulling from the 13 clubs, okay? And we're going to be choosing 2 of them, okay? So out of the 13 clubs, we're going to be choosing 2 of them, okay? Now, you're not done because you've only accounted for 2 of your cards, okay? It is a 6 card hand. So you're going to have to account for the remaining 4, okay? So you're going to, remember, this was kind of like doing fill in the blank. You had the blank for the clubs condition, and now you're going to have a separate blank for the remaining 4 cards, okay? So in the numerator, you're doing the multiplication principle, okay? All right, so to handle the 4 remaining cards, it's still going to be a combination, okay? And we're going to be choosing the 4 remaining cards, okay? But what is that in value going to be? Okay, what are we choosing from? Well, the remaining cards cannot be clubs. So they have to come from the hearts, the diamonds, and the spades. Okay, so if you add up those, the number of cards in those 3 suits, okay, that's going to be 13 times 3, that's 39. Okay, so the 39 remaining cards are from the hearts, the diamonds, and the spades, okay? From that group of cards, you're going to be selecting the 4 remaining, okay? So the numerator here is going to be 13 choose 2 times 39 choose 4, okay? Let's go to the calculator and figure that out. All right, so we're going to have, if I pull this up, we're going to have 13 choose 2. Okay, we get that number, and then we'll do 39 choose 4. Okay. Oh, wow, that's a big number. Okay, so our numerator is going to be 78 times this number. Okay, so let me write this down. So this is going to be 78 times 82,251. Wow, that's big. All right, so we can go ahead and simplify this. Let's take the 82,251, multiply it by 78. Okay, there we go, another large number. Okay, so this is going to be our numerator. Okay, so let's go write that down. All right, so we're going to get, let's see here, this number. Okay, I'll put some commas on here so we can read it. Okay, our denominator is going to be what we had in red. Okay, you definitely do not have to simplify that fraction. Okay, but again, if you go to your calculator, you could get an idea of how close to 0 this is how likely this is to occur. Okay, so we'll just type in this probability just for kicks. The fraction is fine and actually preferable. Okay, but let's see what we get. Okay, so take that number and divide it by the denominator. And there we go. Okay, so that's a teeny decimal. It's definitely, so we got actually what? I'll say 0.315. Okay, so this is 0.315, 129, and it kept going. Okay, so comparing the two situations out of A and B, okay, if you look at the decimal, okay, in part A, we got 0.000304 and it kept going. And if we look at this decimal, 0.315 and it keeps going. This decimal's bigger, okay, so we have a higher probability of being dealt a 6-card hand with exactly 2 clubs. That's a higher probability than is a 5-card hand that consists entirely of face cards. Okay, if you think about it, that makes sense. You would expect that. Okay, all right. So that's a couple of these examples about how you find probabilities of being dealt certain card hands. We're going to try a couple of more in examples C and D.